Hello. In this class, we're going to look at area expansivity. Okay? In physics, we are going to look at area expansivity. One thing you must put at the back of your mind, you can call it area expansivity or superficial expansivity. Either area expansivity or you call it superficial expansivity. Also, put at the back of your mind that it is represented as this. Okay? You represent it with what? With beta. Remember that linear expansivity is represented by alpha. Why this is represented by what? Beta. Another thing is linear expansivity has relationship with area expansivity. That is, area expansivity is equal to 2 multiplied by linear expansivity. So what is the formula? The formula is simply what? Area expansivity is equal to increase in area all over original area multiplied by temperature rise. Okay? Increase in the area over the original area multiplied by rise in temperature, which is increase in temperature. Okay? So the formula is this. Increase in area is simply the new area or the final area minus original area all over the original area multiplied by increase in temperature. You will agree with me, you can represent this like this too by saying increase in area over original area multiplied by this is simply like this. That is change in area. You can also remove this and put what? I put change in area all over original area multiplied by change in temperature. This is what? Area expansivity. You cannot define this now. With the knowledge of this, you can define this comfortably. How do you define it? It is the fractional increase in area, that is increase in area of a substance per degree rise in temperature. Okay? So this is everything you need to know in area or superficial expansivity. Okay? Let's look at volume expansivity. We have treated linear expansivity, area expansivity. Now is volume expansivity. When it comes to this, you can call it cubic expansivity. It means, therefore, so when you see find volume expansivity or cubic expansivity, they are saying the same thing. Okay? Secondly, we represent it by gamma. Thirdly, gamma, which is cubic expansivity, is equal to 3 multiplied by linear expansivity because alpha is linear expansivity. The formula for this, that is cubic expansivity, is equal to increase in volume over original volume multiplied by temperature rise. Okay? Increase in volume over original volume multiplied by temperature rise. Okay? Increase in volume is simply V2 minus V1. Original volume means V1 multiplied by temperature rise. That is this minus this. If you want to put this to the next level, you can use change in volume over original volume multiplied by change. Okay? Still the same thing. How do you define it? It is the fractional increase. It is the fractional increase in the volume of a substance per degree rise in temperature. Okay? It is the fractional increase in the volume of a substance per degree rise in temperature. Okay? So with this now, you understand all of them. Hello. I want you to look at the formula of this: linear expansivity, area expansivity, and volume expansivity. Then we compare. This will assist you to remember them easily. Linear expansivity is represented by this. Is equals to change in length over original length multiplied by change in temperature, which you can say is change, the change in length over original length multiplied by change in temperature. This and this are the same. Why? This is area expansivity. Change in area over original area multiplied by change in temperature, which is change in area over original area, change in temperature. Why this? The volume expansivity is V2 minus V1 over V1 multiplied by change in temperature, which you can write as change in volume over original volume multiplied by change in temperature. Okay? So with this now, you shouldn't have problem with recalling the formulas. Okay? Let's look at this question. It says a solid metal cube of size 10 centimeter. Remember, for a cube, all the sides are equal. Okay? So therefore, the length is given to be 10 centimeter. Is heated from here to here. That is, the original temperature is this. The final one is this. Why? The linear expansivity is 1.2 times 10 raised to the power minus 5. Calculate the increase in this volume. Increase in volume. So this will now take us to the formula that says cubic expansivity is the change volume over the original volume multiplied by change in temperature. The question says what? Calculate the rise in volume. Remember, we can also change this to this. Please, if you have not watched the explanation of this, go and watch it in this channel, okay? Now, we can make this the subject of formula to have this equals to this multiplied by this multiplied by this. Okay? So therefore, you will agree with me that this one is 3 multiplied by this. I explained this too. Okay? So we say 3 times this, which is 1.2 times 10 raised to the power minus 5 times the volume, the original volume. We don't know the original volume because we are only given the length. So the original volume is 10 times 10 times 10. Why? Because volume is equal to this. That is length times length times length for cube. So therefore, we're going to say 10 raised to the power 3 from here to get V, multiply by change in temperature, this minus this, which is 50. All we need to do now is 1.2. You agree with me that this, if you use indices, you're going to have 10 raised to the power minus 2, 50 here. Okay? You can also remove this 0 and put 1 here. The same indices. Multiply by 5. You can also express everything here. Put over 10. Okay? So this is equal to 18 over 10, which is equal to 1.8. And because we are talking about volume, that is change in volume, and this was given in centimeter, that is cm cube. So the change in volume is equal to 1.8 cm cube. Let's look at this. It says the linear expansivity of brass is this. If the volume of a piece of brass is this, at this, what is the volume at 100 degrees centigrade? Okay? The first thing we need to do is to bring out the formula. The formula says that for cubic expansivity, it's change in volume over original volume multiplied by change in temperature. Okay? We are asked to find the volume at this. That means we should find V2. Okay? Because the first temperature was this. It was heated to this. Now, you will agree with me that this is equal to 3 times alpha. 3 times linear expansivity. So we can come in to say 3 times this is equal to V2 minus V1 over V1 times change in temperature. So now, let's make this the subject of formula. Okay? That is to say, V2 minus V1 is equal to 3 this times V1 times this. Okay? Which is equal to 3 this V1 this. Now, you agree with me that V2 now is equal to okay? Let's substitute. This is equal to 3 times this 2 times 10 raised to the power minus 5 multiplied by V1 15 times change in temperature, that is 100 minus 0, this minus this, plus V1. V1 still 15. Okay, that's all. Now we can solve to have 6 100 plus 15. You agree with me? We have 2 0 here. We have minus 5 here. So we can reduce it to say 6 times 15 times 10 raised to the power minus 3 because of this 100. Okay? This is 90. Which is 9 times 10 raised to the power minus 2. Because of this 0, 1 will reduce here from minus 3 to minus 2. If we solve this now, you agree with me, you're going to have 0.09 plus 15. You agree with me, this is 15. You add then 15.09 in cm cube. Okay? C is the answer. Hope you understand this. As you can see, we are looking at real versus apparent expansivity. Okay? When we talk about real expansivity, we are talking about the expansivity of the substance and the vessel that is housing or carrying the substance. While apparent expansivity is the expansivity while you are considering the substance alone. The vessel is not considered. The vessel, the container is not considered, okay? So apparent cubic expansivity which we represent as this, we put A of a liquid is the increase in the volume of the liquid per unit volume per degree rise in temperature. When the expansion of the vessel is not considered. Increase in the volume of the liquid in the container. The increase, that is the rise in the volume, that is the increase in volume over per unit volume, that is the original volume, per what? Rise in temperature. We are still describing the formula. Okay? It means you have this, and this is the liquid. We are only considering this is the original liquid. That is the position correctly. Then, after you heated it up with fire or with whatever, something that was here before has got it to this level. So we are considering this increase in volume, okay, over the original volume. This temperature minus the original temperature. Okay? When you are not considering the expansion of this vessel that is carrying or housing the liquid. Okay? So the apparent linear expansivity is equals to apparent increase in volume. We are using the word apparent because we want to continuously remind you that the vessel is not under consideration. Okay? All over the original volume multiplied by rise in temperature. If this is exposed like this, there is no way liquid will not what? Go out of this container unless you close it. Okay? So this one is when it is closed. But when it is opened, the same formula will be volume of liquid expelled all over of liquid remaining times rise in temperature. But if you want to use mass, you can replace this with mass. Mass of the liquid expelled over mass of the liquid remaining times rise in temperature. Okay? Hope you understand this apparent cubic expansivity. So what about the ring, which you can also call absolute cubic expansivity? This is defined as the actual rise in volume per unit volume per degree rise in temperature. This definition is just trying to cover the formula. The actual rise in volume, all over original volume, also rise in temperature. Just referring to the same thing. So, the real cubic expansivity now, which is the absolute cubic expansivity, is actually equals to the apparent plus the cubic expansivity of the vessel. Remember, this is for both the substance and the what? The vessel. Hope you understand this. Let's look at this question. It says, a relative density bottle of volume 50 centimeter cube is completely filled with a liquid at 30 degrees centigrade. It is then heated to 80 degrees centigrade such that 0.75 cm cube of the liquid is expelled. Calculate the apparent cubic expansivity of the liquid. Okay? What is apparent cubic expansivity again? The apparent cubic expansivity, it is the volume expelled, the volume of liquid expelled over the remaining volume of liquid multiplied by rise in temperature. Okay? That is the volume of liquid expelled over the volume of liquid remaining multiplied by rise in temperature. Okay? Now, what was expelled was this 0.75 centimeter cube. This is the original, that is 50 minus what was expelled to get the remaining one. This is what was taken out. To get the remaining one is the original one minus what was expelled to get the remaining one. Multiply by rise in temperature. We are told this was the original temperature. It was heated to this. That is 80 minus 30. You solve this now, you're going to have 0.0003. That is the apparent cubic expansivity. Okay?